Hello and welcome to my entry for the Flashing Light Prize 2018. This is a neon bulb, beautiful neon light in fact, that's flashing. I would like to thank you for the excuse to actually buy this because I've wanted to buy one. They're beautiful, but this is an ideal excuse. I really needed an excuse. Anyway, as you can see, it's flashing as required by the competition rules. Once a second, about even on and off. Well, how's it doing this? Well, I took a slightly alternative approach. Because I was searching for the bulb and I came across these. These are testers for dog shock collars, and I realised, well, a dog shock collar will light up a bulb, so that's what I got. I got one of these dog shock collars, and there's the tester on top. It does actually work. I don't recommend using these on your dog. It just seems a bit not very nice. Anyway, so I connected that up to the bulb, which would normally plug in. It's perfectly safe, absolutely perfectly safe. I know it's perfectly safe because it's opto-isolated. Let me explain further. I needed to send out a pulse to control this. So instead of using the controller, which would normally if I turn it on and press that, it would just send the signal out to be on. What I'm doing over here, in fact, I'm amazed that happened at the same time, because over here I've got a little 433 megahertz transmitter. I backwards engineered the protocol used, and there's just a little Arduino on there which is sending the signal out. It actually sends the signal out twice to make sure it stays on for exactly half a second. I'm wondering what's making a noise there. Oh, we'll come back to that later, it'll be fine. If there's fire, I'll drop the camera and deal with it then. Okay, so this is sending out the signal, and as if you press a thing, send the signal out twice. That's 500 milliseconds on. I know I wrote some Arduino code to actually test that with the light sensor. I'll bung that on GitHub if you want to use it to test your own. In fact, I'll put the code for running this on GitHub just in case you want to electrocute a light bulb yourself. So that's sending the signal out, and that stays on, but we need to have a pulse every second to kick that off. So you probably noticed at the front here, little light sensor, and it's sort of flashing a bit. What is actually received there is a laser beam from the MSF time signal. It's a time signal sent out. It used to be rugby, didn't it? I can't remember where it is now. But it sends out a pulse every second. On the minute it sends out a very long pulse, and just after the pulse it puts another couple of bits of data in every second that they're all added together. I'm not interested in that. I'm only looking for the initial pulse, which I do on the Arduino here. So that's where the light's coming from. If we go over here, we have the laser diode that is emitting the light. This is connected via a MOSFET to 60 Hz tuner module, an MSF clock module, and there's a little coil on there which is helping pick up the signal. It doesn't really need to be on the peg at the top there, it just looks nice. This is all battery powered, by the way. It's all lithium-ion batteries. Let's not look too closely. As I said, it's all opto-isolated, and in fact, it's very opto-isolated because the light goes up to there. That's bouncing to, where is that bouncing? It's bouncing over here, which is then bouncing down to there, which is up to there, which is then going up to there and down to there and doing that. So if at any point that the light stops flashing, it's because I put my hand in the way with the camera, and that's it. It is flashing away, and I suppose it should make it flash for a minute. In fact, I'm going to turn the lights off for a bit so you can fully enjoy what it's like. Well, that must be a minute now. I should have checked when I did it. I'll make a small confession here. If you're watching this video, something's gone wrong. Our intention is one early morning on a Sunday before the building's officially open. We're going to put the receiver, the MSF receiver and module on the top of the stairs. That's going to shine the light down through the middle of the stairwell. 9 flights of stairs down to the basement. The building only technically has 6 floors, but we actually have 9 flights of stairs, and then bounce around all the mirrors to the workshop, which we're now in the basement. But the fact you're watching this is my backup video, so it obviously didn't work too well. I hope you liked it anyway. It's been great fun. Okay, cheers, bye.